In this video, we're going to solve question 49 of the 2021 Junior Mathematics Olympiad first round. We have to find the number of diagonals a regular dodecagon thus a 12-sided polygon has. Okay, so there are two important observations that we're going to make use of while solving this question. And to talk about that, I'm going to draw a pentagon. So here is a pentagon. And I'll label the vertices A, B, C, D, and E. So here we have A, B, we have C, we have D, and we have E. So the first observation we're going to make use of here is to notice that every pair or every unordered pair of non-adjacent vertices form a diagonal. So let me write that down here. So every unordered pair of non-adjacent vertices forms a diagonal. Okay, so before I continue, I'll just explain some things here. So by unordered, we mean that what vertex comes before which does not matter. For example, the pair BE is the same as the pair EB. Since we're saying that the order doesn't matter, that's what unordered means. So the pair of vertices B and the pair of vertices BE is the same as the pair EB. That's what unordered means. And then the second term we used here was non-adjacent. So by this we mean that the two vertices should not be next to each other. So for example, we can't count AB. We can't count AB here because the vertices A and B are next to each other. We only want vertices that are not next to each other, like EC or AC. Okay, now to demonstrate how this first observation makes sense, let's say we pick the pair of vertices B, D. For example, if you join B and D, you have a diagonal. If you pick the pair CE, so the pair CE, if you join C and E, you have a diagonal. Notice that C and E are non-adjacent vertices. B and D too are also non-adjacent vertices of this shape. If you pick the pair, let's say AD, so if you pick the pair AD or DA, since they are the same, you also have another diagonal of this shape. So that's the first observation that we're going to make use of while solving this question. Then the second one is that every diagonal is formed by an unordered pair of non-adjacent vertices. Let me write that down here. So every diagonal is formed by an unordered pair of non-adjacent vertices. Okay, to demonstrate this, I'm going to draw a second pentagon. So I'll draw that down here. And as before, I'll label the vertices A, B, C, D, and E. So we have A, B, C, D, E here. So let's say we pick a random diagonal in this shape. Let's say diagonal, this diagonal here marked in red. Notice that this diagonal is at the ends of this diagonal, you have the vertices B and D. So this is an unordered pair of non-adjacent vertices. If you pick any other diagonal of in this shape, let's say you pick this diagonal here. At the ends of this diagonal, you have the vertices A and C, and this is an unordered pair of non-adjacent vertices. If you pick this one, you have the unordered pair of non-adjacent vertices EB or BE, since we said that the order doesn't matter. So that's what the second observation tells us. That's like the second observation we're going to make. So based on these two observations, now we can come to the conclusion that the number of diagonals of this shape, that's therefore the number of diagonals is going to be equal to the number of unordered pair, pairs of non-adjacent vertices. In fact, in these two observations, we can add unique, right? So every unordered pair of non-adjacent vertices forms a unique diagonal. That's important because if you pick any pair of non-adjacent vertices, there's one and only one diagonal that it will form, and this one. So every diagonal is formed by a unique unordered pair. So this will be by a unique unordered pair. So no diagonal is formed by two pairs of vertices. So it's based on these two observations now that we can come to the conclusion that the number of diagonals is equal to the number of unordered pairs of non-adjacent vertices. So since we're asked to find number of diagonals, we can instead find the number of unordered pairs of non-adjacent vertices. So before we go ahead to solve the full question, which is for a 12-sided polygon, we'll just do this with a smaller shape like a pentagon, as we've always used. So let me draw another pentagon here. So here's a pentagon, and we'll label the vertices A, B, C, D, and E. So let's say we're trying to generate unordered pairs of vertices of this pentagon, right? Or let's say we're trying to generate pairs initially. They're going to be 5, that's pairs of non-adjacent vertices. We're going to have 5 options for the first item of that pair, since we can pick any vertex to be the first item in that pair of vertices. And then for the second vertex, notice that while picking the second vertex, we can't pick the pair that we've used. We can't pick the vertex that we've used before. For example, let's say we picked this vertex A here. When picking what the second vertex of that pair will be, we can't use A again. And at the same time, we also can't use any of the two vertices that are adjacent to A. So we can't use B and E because we're looking for non-adjacent vertices. We look close, remember we have non-adjacent here. So what that means is that for the second vertex of this pair, we're going to have 5 minus 3. We're having minus 3 here because we're excluding the vertex we already picked and the 2 next to it. That's 5 minus 3. So this number of pairs of diagonals you have. And then remember, we are looking for number of unordered pairs, right? So it doesn't matter if we pick B before E or E before B. So since we're looking for the number of unordered pairs, we're going to divide by 2 to account for the permutations. That's since in this 5 times 5 minus 3 possible pairs, we're going to have something like AB and also have BA. So we're going to divide by 2 since AB and BA are both the same thing. And so for a 5-sided polygon, this is what you will have. This number of diagonals that shape will have, that will be 5 times 2 divided by 2, which will be 5. Okay, and then for a 12-sided polygon, while picking the first vertex of a pair of non-adjacent vertices, you're going to have 12 options. And then for the second vertex, notice that you can't pick you can't pick the vertex you picked the first time, and also can't pick the 2 ones next to that. So you're going to have 12 minus 3 options for the second vertex of the pair. And since some things will occur twice and we're looking for unordered pairs, we're going to divide by 2 here. So this is going to be 12 times 9 divided by 2, which will be 6 times 9, which is 54. So a 12-sided polygon is going to have 54 diagonals. That's how to solve this question. A second way of going about this ending part, that's a second way of counting number of unordered pairs of non-adjacent vertices, is to start by counting the number of pairs of vertices we have, and then subtracting the number of pairs of vertices that are made up of adjacent vertices. Okay, let's just do that briefly here. So let's say we're looking for the number of pairs of vertices that we have. That's unordered pairs. They're going to be 12 that's 12 choose 2 of them, right? Since we can just pick any 2 vertices of any 2 of the 12 vertices, and then that'll be a pair of vertices. So we're going to have 12 choose 2 or 12 combination 2 of them. That's going to be 12 times 11 divided by 2, which is 66. So there are 66 pairs of vertices in a 12-sided polygon. But remember, we're looking for non-adjacent vertices, right? That's, we're looking for pairs formed by non-adjacent vertices. So this 66 pairs is made up of some pairs that consist of adjacent vertices and some that have non-adjacent vertices. So we're going to count the number of pairs that have adjacent vertices and subtract that from 66. So notice that if you have a pair of vertices formed by adjacent vertices, then that pair is going to form a side. For example, in this polygon here, the pair BC is a pair of adjacent vertices. And if you join B and C, you will have a side of this polygon. The pair DE is formed by adjacent vertices. And if you join D and E, you have a side of the polygon. So every pair of adjacent vertices is a side of the polygon, and every side of the polygon is a pair of adjacent vertices. And since a 12-sided polygon has 12 sides, it means that a 12-sided polygon is going to have 12 unordered pairs of adjacent vertices. So out of these 66 total vertices that we had here, 12 of them are going to be adjacent vertices. It's going to be made up of pairs of 12 of those pairs are going to be made up of adjacent vertices. So have 12 adjacent pairs. And since we're looking for just the pairs that are made up of non-adjacent vertices, they're going to be 66 minus 12, which is 54 of them, and we'll still arrive at the same answer that we got the first time. So that's how to go about solving question 59 of this exam.